Okay, so in Chapter 6, we are going to talk about polygons in general, and then more specifically, we're going to talk about quadrilaterals. So in this first lesson, we're going to talk more broadly about the sums of the angles of a polygon, both interior and exterior. So we're going to learn about something called the polygon angle sum theorem, and that states that the sum of the measures of the interior angles of an N-Gon is n minus 2 times 180. So in example 1, we're going to talk about what N-Gon really means. N-Gon just means the number of sides. N represents the number of sides. So in example 1, N is 7 for a heptagon. It has 7 sides. So the way we find the sum of the interior angles of a heptagon is we take the number of sides, 7, minus 2 times 180, which is really 5 times 180, which equals 5 times 180 is 900 degrees. So all we do is we take the number of sides, which is really the number of angles, minus 2, and multiply that by 180. So quickly work through the guided practice, and then, pause the video first, but work through the guided practice, and then when you're ready, move ahead, and we'll talk about something else with interior angles of a polygon. All right, so to explain the guided practice, number 1, pretty straightforward. You substitute 17 into the formula. So 17 minus 2 is 15. 15 times 180 is 2,700, or 2,700 degrees. In part B, that's a little bit tougher, but it's what we're going to cover next, is to find the number of sides. So basically approaching the problem from a different angle, you set up some sort of equation where the sum is equal to the number of sides minus 2 times 180. So you'll see on the right, I set the sum equal to n minus 2 times 180. I divided both sides by 180, and I got 11 equals n minus 2. The number of sides would then be 13. So we're going to get some practice doing that, finding the number of sides, okay? So working our way back from that. So just a quick recap. We've talked about this before, but an equilateral polygon, not triangle, equilateral polygon, all of its sides are congruent. In an equiangular polygon, all angles are congruent. In a regular polygon, all angles and all sides are congruent, so it's equiangular and equilateral, meaning all of the angles are the same measure, all of the sides are the same length. So we're going to kind of go through what we did in the last example or last guided practice and talk about the corollary to this, which means to find the measure of each interior angle of a regular N-Gon, meaning all angles are the same measure. We take this, n minus 2 times 180, divided by the number of sides, so divided by n. So if we have a nonagon, a 9-sided polygon, that means n equals 9. So to find the measure of each interior angle, we're going to take 9 minus 2 times 180 divided by 9. So 9 minus 2 is 7. So 7 times 180 divided by 9. 7 times 180 is 1260. 1260 divided by 9 is 140. 140 degrees. So each angle is 140 degrees. So we're just dividing out that sum equally among the number of angles, essentially. So moving ahead, using our theorem to find a missing angle, okay? And this isn't a huge stretch. All we're doing is we're trying to find the measure of angle y. So I'm just going to say the measure of angle y, let's just use a variable. Let's just use x, okay? Now, what we'd want to do, since we know all the other angles, we want to know the sum of all of the angles of the polygon today. It's pentagon. So this has, it has 5 sides. So to find the sum, I'm going to take 5 minus 2 times 180, which is 3 times 180, which is 540. So a simple way to think of this is if I know all but one angle of a polygon, I can take that sum and basically just subtract all of the known angles from that sum to get the remaining angle. So to do that, I'm going to take 540 minus 110 minus 90 minus 120 minus 150. So I'm subtracting all of the known angles to find the value or the measure of angle y. So that means the measure of angle y is 70 degrees. So I'm going to write the measure of angle y is 70 degrees, okay? Now if I had 2 unknown angles that were the same measure, I would just divide the remaining, value by 2. So we're going to get into some more examples like that once we start practicing. But guided practice does kind of the same thing. Find the sum, subtract all the known angles from the sum. And then for guided practice 3, for that regular hexagon, remember, do the sum and then divide it by the number of angles or the number of sides. So pause the video. Once you're ready to move on, resume the video, check your answers, and then we've got one more example to cover. Okay, so as far as the guided practice goes, I found the sum. Number of sides is 4, so 4 minus 2 times 180 is 360, and then I just simply subtract all the known angles from 360. The thing that I want you guys, and there's not much I'm going to really want you to totally memorize, but we've memorized the sum of the angles of a triangle is 180. The next step for quadrilaterals, because those are the next most common shape we work with, the sum of the angles of a quadrilateral, a 4-sided shape, is always 360. Okay, that's an important one because we're going to work with those throughout this whole chapter. Okay, in example 3, it's just finding the sum of a hexagon, a 6-sided shape, and then dividing that by the number of congruent angles, which is 6. So 720 divided by 6 is 120. So finding the measure of each angle of a regular polygon. Our final example, I think, is a little bit easier to follow because this is uniform throughout every polygon in existence, the exterior angle sum. So the exterior angle of a polygon is if I extend a side and create an angle with that extended side and an existing side. So if I extend one of the sides, this one exterior angle is 80. Another one is 150. Another one is 130. Every polygon, the exterior angles will add to equal 360. That's uniform for every polygon, whether it's 3 sides or 10 sides. So we can draw exterior angles at any vertex. Now, if we extend a side a certain way, we have to extend the next side kind of in the same direction. We'll kind of go through examples of that. So identifying an exterior angle and understanding that the sum is always 360 for any polygon, for exterior angles. So in example 4, we're finding a single exterior angle measure. And it says, what is the measure of angle 1 in the regular octagon at the right? So the measure of angle 1 is going to be right here. The thing I want us to understand is that since this is a regular octagon, all of the interior angles are congruent, which means all of the exterior angles are congruent. It also means finding an exterior angle, we know the sum of the exterior angles of any polygon is 360. So to find the measure of one or each of the exterior angles, I'm going to divide it by the number of congruent angles. So 360 divided by 8 is 45. So the measure of angle 1 is 45 degrees. So it's just the knowledge that the sum of the exterior angles of any polygon is 360. If it's regular, to find the measure of each angle, divide it by the number of angles. So there's a couple things going on here, but the concept of it is just a few formulas we've got to work with and know which formulas to use when. Okay? So you're probably ready for some sort of practice on this so you can move ahead to the next step in our lesson.